Okay, in this video we are going to study the concavity theorem. And as you can see, the concavity theorem says that if the function f is twice differentiable at x equals some number c, then the graph of f, your function, is concave down upward at c f of c. If f by prime of c is greater than 0, and concave downward if f by prime of c is less than 0. That means that if we are going to use now the second derivative of functions, and we are going to test the values for x that we were finding and into the second derivative. If our answer has a positive value, then that means that the function is concave upward, and concave downward if your substitution on in the second derivative is negative. Okay, just to show you, concave upward is something like this. Okay, this is concave upward, concave upward. And the other thing that I was telling you about is concave downward. Okay, let's write here concave downward. Okay, so this is pretty much what the theorem says. Okay, I guess we are done for now with this theorem, and let's try an example so I can show you how we are going to use this theorem. Okay, let me write an example in the next slide. Okay, I'm going to use this example. Let me just write the function that I'm going to work with, just to show you how this works. It is some function f of x equals 3x to the fourth minus 4x to the third minus 12x squared plus 3. Okay, so what I'm going to do now is just the very first step that we have followed till today, which is to find the first derivative of our function. So the derivative of this function is 12x to the third minus 12x squared minus 24x. Okay, so the second step was to set our derivative equal to 0. So it's our derivative. I'm just copying the derivative, and I'm going to set this equal to 0. Okay, then I have to factor in order to solve this equation. Okay, I want to solve this equation. The solutions of this equation, the derivative of a function, are going to be my either my maximum or minimum, or the lowest or the highest point of my function in this example. Okay, so I guess my first, I can take out the common factor, 12x, which is going to be multiplied by x squared minus x minus 2 equals 0. And then I have to keep going, x here, then it's minus and then positive sign, so I have to find two numbers whose product is minus 2 and whose sum is minus 1. I guess those are 2 and 1. Okay, so I can see that I have three solutions. One is 0, the other one is 2, and the third one is minus 1. Okay, so these are called critical points. That's how they are called. They can be either or maxima or minima. I'm going to write it, critical points, in case that you find them searching on the internet or in some textbook. Now, remember that what we did was to use the first derivative to find out either if which one of these was the maximum or which one were the minimum points. And but in this case, I'm going to use the second derivative. Okay, so I'm going to find the second derivative down here. The second derivative. I'm going to use the second derivative to identify which one is what, either a maximum or a minimum point. So the second derivative will be 36x squared. And what else? 36x squared minus 24x, and the last term is going to be minus 24. Okay, that is the second derivative. So what I have to do now is to evaluate each one of these points into my second derivative. So I have to find f by prime of 0, for example, which is going to be minus 24. So as you can see, I got a negative answer. Okay, so I have a negative answer. And I'm going to evaluate my second answer for the first derivative. 2, what is that going to be? It's going to be 36 times x squared, or 2 squared. Okay, so with when I evaluate 2 into my second derivative, I get 72. So I got a positive answer. Okay, now I have to evaluate my third value, my last value, into the second derivative. Is going to be f by prime of, what was my other value, x3. It's minus 1. So I have to evaluate with minus 1. And so as we can see, I'm going to get 36. So it's again a positive answer. Okay, so now what are we going to do with these results? So what we're going to do, or we're going to use the theorem. This is telling us this part, that when x equals 0, the function is concave down. So it is going to be something like this, concave down. The other answers, which were positive answers, are positive answers. Means that at these points, when x equals 2 and when x equals minus 1, the function is concave upward, because my second derivative was positive. So I can see which one is a maximum and which one is a minimum point. In this case, because my function is concave down, I can see that this point, or when x equals 0, my function has a maximum point. So I'm going to write a maximum point, because I have my function is concave down. Then in both of these cases, my function, my second derivative is positive, so my function is concave up. I have a minimum point. You can see that from the shape of the drawing next to this. So it's a minimum point, and again I have a minimum point here. Okay, so I guess all that's left is to sketch the graph of my function, of this function. So I think I can have it here. Let's sketch it here. I'm going to have my xy plane here, place. I'm going to label my axis. This is the y-axis, and this is the x-axis. So I have to find my points. In this case, what are my points going to be? I have a point which has a 0 as the x-coordinate. I have another point which has 2, and my last point which has -1. So I have to evaluate, to find the y coordinate. We're going to proceed in the very same way as before. We have to evaluate these values for x into my original function, into our original function. So what are we going to get? With 0 we have 3, okay? So our answer is 3. Now let's go with when x equals 2. If I evaluate my function when x equals 2, I'm going to get negative 29. Now what happens when x equals negative 1? When x equals minus 1, if I evaluate on my function, I'm going to get minus 2. Okay, so I have my 3 points, 0 and 3. 0 and 3, I'm going to use another color. 0 and 3, let's say it's located around here. Okay, it is a positive value. I have 2 and minus 29. 2 and minus 29, that's a large number. So let's say it's around here. And the last number is minus 1 and minus 2. So it should be around here. Let's say it's around here. So I can see what the shape of my function is going to be. The function here is in concave up. So you can see it's concave up. This is concave down. I'm sorry. This is concave down. And here my function is concave up. Okay, so this is a very rough sketch of my function. Okay, here it is. That is how we are going to use the second derivative on these examples. Thanks for watching.